Okay, students, the next technique in immunoblotting is Western blotting. So, Western blotting is an analytical technique used mostly in molecular biology and in immunogenetics and other molecular biology to detect specific proteins in a sample of tissue, homogenate or extract. So, Southern blotting is used for detecting DNA fragments, but the Western blotting is used to detect the proteins present in a genetic component. And the procedure is similar to that of Southern blotting. So, the main difference is in between the Southern blotting and Western blotting is that the Southern blotting is used to detect DNA and Western blotting is done for detection of proteins. So, the Western blotting is also known as protein immunoblotting because an antibody probe is used to specifically detect its protein. So, the final step in Western blotting, the incorporation of an antibody probe, and this antibody probe is helpful for detecting the specific protein and that particular gene. So, these are the steps involved in Western blotting: protein gel electrophoresis, protein transfer, blocking, antibody probing, detection. Okay. First step is the protein gel electrophoresis. We are using sodium dodecyl sulfate polyacrylamide gel electrophoresis, and this sodium dodecyl sulfate polyacrylamide polymer has the negative charge, and this negative charge attract to the protein component, and all separated proteins in gel are negatively charged. We get the proteins of negatively charged protein molecules. So, this sodium dodecyl sulfate polyacrylamide gel electrophoresis, when we are applying this SDSPAGE to the protein component, and that protein component occurs the negative charge, and this negatively charged protein component can be separated by using gel electrophoresis. The next step is protein transfer. Now we are using nitrocellulose membrane because of some reason. So we are using nitrocellulose membrane. This nitrocellulose membrane have high affinity for proteins. So the gel consisting of the protein is transferred to nitrocellulose membrane. In gel electrophoresis, as usual, the gel and membrane is placed in a electrophoretic chamber, and gel is connected with a negative charge and the membrane is connected with the positive charge, and the negatively charged protein move from gel to membrane. So we get a negatively charged protein in nitrocellulose membrane. So apparatus design, and the whole assembly is immersed in a methanol. So in a transfer buffer, it acts as a transfer buffer. So the protein in the gel, that is negatively charged protein in the gel, transfer to membrane, that is nitrocellulose membrane. When we are applying a negative charge to the gel, and when we are applying a positive charge to the membrane, so we get to the negatively charged proteins on that particular membrane. So this is a membrane with a band pattern of protein. You can see the band pattern of protein in nitrocellulose membrane. Next step is blocking. This blocking is usually done to prevent the non-specific binding of antibodies, and we are using blocking agents as non-fat milk, bovine serum, albumin, because the membrane consisting of as we know that the membrane consisting of proteins, and some other proteins interfere with our result, and that will be blocked by using a non-quantity of blocking agents like a non-fat milk, bovine serum, aluminum. Next step is antibody probing. The antibody probing, as usual, the membrane is incubated with a primary antibody. Antibody binds with the proteins present in the membrane. Then washing leads to wash out of unbound antibody from membrane. That is, probe antibody is incorporated with our protein in nitrocellulose membrane. So this probe antibody attached to the protein present in the membrane. The remaining will be washed out from the membrane, it is nitrocellulose membrane. And the final step is detection. Membrane is incubated with the labeled secondary antibody. Then we are added the labeled secondary antibody. Then again we are done for washing. That is unbound labeled secondary antibody washed out from the nitrocellulose membrane. So we get in nitrocellulose membrane, we can see that a protein, probe antibody plus labeled secondary antibody complex. So this complex can be detected. On detecting this complex, we can assume that the particular protein is present on that nitrocellulose membrane. So the secondary antibody. What is secondary antibody? The labeled antibody is an antibody which consists of an enzyme. The secondary antibody binds to the primary antibody membrane, can be detected by adding substrate naphthol, that is 4-chloro-1-naphthol. The substrate added is forms insoluble purple color with the target protein. So the secondary antibody is an enzyme-linked secondary antibody. That enzyme-linked antibody binds with the primary antibody. That already the primary antibody binds with the proteins in the nitrocellulose membrane. So the secondary antibody, primary antibody, protein complex in the nylon membrane. So when we are adding a substrate like a 4-chloro-1-naphthol to that particular nitrocellulose membrane, we can find out the purple color with the target proteins. So the identification by observing the purple color produced in the nitrocellulose membrane. So what is the reason behind forming this purple color on the nitrocellulose membrane? It is due to the protein, primary antibody, secondary antibody binding. And the specific protein is present on the nitrocellulose membrane. The primary antibody will definitely bind to the protein, and definitely the secondary antibody bind with the primary antibody. So this complex will formed. So when we are adding a substrate like a 4-chloro-1-naphthol to that particular nitrocellulose membrane, okay, we can find out the purple color develops in the nitrocellulose membrane. So detection is by using the development of purple color due to the formation of protein, that is protein coming from our sample, and the primary antibody and the secondary antibody complex. Then these are the applications of Western blotting: identification of a specific protein in a complex mixture of proteins, then estimation of the size of the protein as well as the amount of protein present in the mixture. It is mostly widely used as a confirmatory test to diagnose of HIV. We are taking the HIV proteins and we can find out the diagnosis of HIV, where this procedure is used to detect, determine whether the patient has antibodies that react with one or more viral proteins or not, and the demonstration of specific antibodies is the serum for diagnosis. So the Western blotting is used mostly in the case of the detection of or the diagnosis of proteins present in the sample. So Western blotting is used for the detection of proteins present in the sample. Okay, thank you.